Hello friends, this video on carbon and its compound part 10 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 9. Hydrocarbons. As the name suggests, hydrocarbon is nothing but hydrogen plus carbon. Correct? So, compounds made of hydrogen and carbon only. Please note, compounds made of hydrogen and carbon only are called hydrocarbon. For example, CH4 methane, C2H6 ethane, all these examples of hydrocarbons. Correct? And there are various types of hydrocarbon. The first is aliphatic hydrocarbons. In aliphatic hydrocarbons, I have long chains, or you can say non-cyclic chains. Right? So I have like this, or I can have something like this. The branched version also is okay, right? So that's called aliphatic. I have saturated. In saturated, I have alkanes. I have unsaturated hydrocarbons. In that, I have alkenes and alkynes. I also have cyclic hydrocarbons. So in this, we have cyclic chain, for example, like this. Something like this, right? It is cycle form. So it forms a cycle. So it can be, in this case, it is 5. It can have 6 also. Let's study more detail. So it has 6 now, right? So it's cyclic hydrocarbons. There I have cycloalkanes, and then I have arenes. Arenes are aromatic. I'll tell you why this name came actually. Arenes. Normally, before actually finding the structure and all, they used to classify it based on the smell, because these things came later, right? Because when they formed, found that the carbon has these many atomic numbers, this is the valence electron it has, and it does all this bonding. All this study came later, but before that only they have this benzene, they could smell the benzene, and all these arenes generally have a good smell, and that's why they are also called aromatic compounds, so hydrocarbons. So you can leave this now. Just understand that we have aliphatic, where we have a non-cyclic chains, long chains. In that I have saturated and unsaturated. For saturated I have alkanes, for unsaturated I have alkenes, alkynes. In cyclic hydrocarbons I have cycloalkanes, that is, you can say saturated, and arenes, that is unsaturated. Right. So we'll study more detail for all this. So let's start with the saturated alkanes, and this is part of aliphatic, right? This is the long chain. So hydrocarbons are bonded exclusively by single bonds in this case. There is no double bond, all single bond in this case. For example, you take CH4, C2H6, 3,3H8, C4H2. You draw the structure of these methanes. If you see CH4, all the carbon hydrogen bonds is all single bond, right? Here all single bond. Here also, if you see, the bond between carbon and carbon is single bond, ethane, right? That's 2 carbon and 6 hydrogen. If you take propane also, there are 3 hydrocarbons and 8 hydrogens, and all are single bonds. Butane also, if you take butane, in case of butane, all are single bonds, right? 1, 2, 3, 4 carbon, all are single bonds. Correct? So one more example is the pentane. 1, 2, 3, 4, 5 carbon. I'll tell you the naming convention of all these, how the name came and all. Just understand that these are some of the hydrocarbons which are all saturated, and they are all called alkanes. If you see the name ane, alkane, ethane, propane, butane, pentane, right? All these are all alkanes because they have all single bonds, and they have the general formula of CnH2n plus 2. You can put any value of n. For example, you put n is equal to 1. This becomes C1H2 into 1, 2 plus 2, 4. C1H4 is nothing but CH4, this guy. You put n is equal to 2. This becomes C2H, 2 into 2, 4 plus 2, 6. Right? C2H6 is this guy. It's called ethane. You put n is equal to 3, C3H, 2 into 3 is 6 plus 2, 8. That is C3H8 is propane, right? If you put n is equal to 4, H becomes 2 into 4, 8 plus 2, 10. That is C4H10, that is butane. Similarly, if you put n is equal to 5, this becomes H12, that is pentane. And the list increases. It's not that pentane is the end. There are so many other hydrocarbons which are alkanes, right? I'll explain all these things and I'll go to the naming nomenclature of this. But just understand this is now that saturated hydrocarbon is something which are bonded exclusively by a single bond. Single bond is the mantra here. And they are chemically unreactive because the name suggests saturated means they are saturated in life, they don't want to react much, and they are chemically unreactive. So just a memory tip, saturated means it's like a saint, saturated, and they are not reactive. Unsaturated hydrocarbons, there are two types, one is alkene, the other is alkyne. So I'm taking the alkene first. So alkene, they are bonded by a double bond. Please note a double bond. It can have a double bond. If it has one double bond also, it will be called as alkenes. Correct? For example, C2H4, C3H6, C4H8. They are all alkenes. They have double bond. I'll show you the structure of these. You see C2H4 is ethene. Please note here there is nothing called methane here because there in case of alkane we start with methane CH4, right? But here I'm talking about there should be one double bond between carbon and carbon. That is, I'm talking about two carbon atoms. I'm not talking about single carbon atom because if I'm talking about only one single carbon atom, there can't be a double bond between two carbon atoms. Correct? Because here the definition says where the carbons are bonded by a double bond. So for a double bond to exist, it should have minimum two carbon atoms, and that's why there is no methane here. Correct? This is ethene. The first element is ethene. So ethene, if you see, is C2H4. There's a double bond here. You see propene, there's a double bond here. If you see butene, there's a double bond here, right? If you see pentene also, there is a double bond here, right? So that's how it is. So if you have one double bond, that particular hydrocarbon is ene, alkene. If you see there's a ene here, alkene, propene, butene, pentene, ethene, right? There's an ene word here because there is a double bond. And if you want, you can write the electron dot formula also. You'll feel that yeah, there's a double bond required because see, carbon has 4 atoms, 1, 2, 3, 4. It got 2 from these hydrogens. It got 6. Now it needs 2 more. So it will form double bond with this carbon. So it got 8 now. Correct? And similarly for this carbon, same thing. And that's why it has double bond. So you can draw the electron dot structure for any of these and find that everything is satisfying actually. So this means there's an electron here. Ends has an electron actually. That's how it is. Right? So if you see there's an electron here, there's an electron here, here, there's an electron here. Just put electron in the ends and you'll find that all these atoms satisfies its electrovalence cell. For example, hydrogen needs 2, it has 2. You take any hydrogen, it has 2, right? Carbon needs 8. So you can take any carbon atom, this carbon atom you take 1, 2, 3, 4, 5, 6, 7, 8. You take this guy, it has 1, 2, 3, 4, 5, 6, 7, 8, right? You take this guy is 1, 2, 3, 4, 5, 6 from 3 hydrogens and 7, 8 is carbon. So if you see everything is satisfied, right? All the elements satisfies the stable configuration. And the general formula of alkene is CnH2n. Please note in alkene it was 2n plus 2. In this the general formula is CnH2n and they are chemically reactive. Please note they are unsaturated and they are reactive. Right? So you can use the same thing, you put the value of anything. You can't put n is equal to 1 because that's not possible. There has to be a double bond. Correct? And then you will take n is equal to 2 is the starting one here. You put n is equal to 2, this becomes H equal to 2 into n, that is 4. C2H plus ethene. You put n is equal to 3, H becomes 6. That is propene. You put n is equal to 4. H becomes 8, becomes butene. N is equal to 5, H becomes 2 into 5, 10. That is pentene. This guy is C5H12. So that's the general formula of alkenes. And then we have something called alkynes. and they are bonded by a triple bond. Please note they are bonded by a triple bond, right? So here we have C2H2, C3H4, C4H6 are examples of alkynes. For example, ethyne, if you see, it is C2H2, this triple bond here. Propyne is this structure, butane is this, pentyne is this. If you see, if you write the electron dot structure, you'll find that this is how it is, 3 here, 3 here, like this. This carbon needed 8, so it took, it had 4, it took 1 from this hydrogen, got 5, it needed 3 extra, so it formed triple bond with this guy. So now if you see, this guy has 8. Similarly, you can do with other things also, right? So that's how it is. And the general formula is CnH2n minus 2. Please note this is minus 2, and they are chemically very reactive. Same thing, we apply the formula. We can put the n is equal to 2 here. This becomes 2 into 2, 4 minus 2, that is 2, C2H2, that is ethyne, right? We put n is equal to 3, it becomes 3 into 2, 6 minus 2, that is 4, C3H4, that is propyne, this guy. You put n is equal to 4, this becomes 4 into 2, 8 minus 2, that is 6, C4H6, that is butane, and then you have C5, H becomes 5 into 2 is 10 minus 2, 8, that is pentyne. This guy is a pentyne. See, there's ine here because all alkynes, right? So it has all ines here. And the way it works is, I'll tell you the naming convention, how it works in the next few slides, right? How this got the name ethyne, propyne, butane. So we'll study all these things, don't worry, but just understand in this cases, in case of saturated, we have alkanes, and the formula, general formula is CnH2n plus 2. They are saturated, they are alkanes. Then I have CnH2n, that is alkene, and then I have CnH2n minus 2, that is alkyne. Correct? And now there is a memory tip to remember this aliphatic hydrocarbons. I have alkane, alkene, alkyne. If you see, first 3 are all same, so you can ignore. And then if it's A, E, Y, alphabetically, if you see that, this guy is A, this guy is E, this is Y. And the last 2 are also same, but the only thing differs is A, E, Y. That means you see, alkane comes first, alkene comes second, alkyne comes next, right? And then also here also, if you see, this is CnH2n plus 2. You keep decreasing 2 elements. You remove 2 from this, it becomes 2n. You remove 2 from this becomes 2n minus 2. And that's the memory tip actually. So 2n plus 2 is alkane. The next will be E, alkene, 2n. And the next will be alkyne, Y. That is 2n minus 2. And that's all alphabetic, right? A, E, Y. That's just a memory. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.